Hi, welcome to Data Within Reach, and welcome to another Rapid R 3-minute tutorial. When I first started this series, I made the 3-minute constraint to try to create these sort of bite-sized tutorials that people could get through quickly. The thing is, as the topics get more complex, it becomes harder and harder to meet that 3-minute constraint. So forgive me if I go over 3 minutes for this tutorial. And the reason why is because today we're going to go over how to do Kalman filters in R using the stats library. First, let me explain what a Kalman filter is. The way I'm going to explain Kalman filters is I'm going to borrow from the explanation that was given to me in a Georgia Tech class on using artificial intelligence and robotics. The class is CS-7638. In the lecture for this class, they displayed a two-dimensional graph like the one I'm showing here. And on the x-axis, you can see location. And on the y-axis, you have velocity. So this is like a one-dimensional example, a really simplified version. If we know at time equals 0 that a thing, I don't know, a car, a robot, a particle, whatever, you might be a little bit wrong about where it is, so there's a little bit of uncertainty to the left and to the right. And if the y-axis represents velocity, well, there's a ton of uncertainty because you just don't know what the velocity of it is. So the Gaussian distribution of what its speed is versus where it is looks like this. It looks like this really stretched out oval. Now, what happens when time equals 2 or time equals 7? Well, now we have a second data point we can look at, and now we can actually figure out, since it moved, we can figure out an estimate of what its velocity is. And so as a result, you now actually have a Gaussian distribution that looks like this. Leaning sideways thing, because if it actually moved farther, well, then it's actually going faster. And if it didn't move as far, then it's actually going a little slower. So the power of the Kalman filter is that based on these measurements, you actually are able to gain more information out about your system. By looking at location and taking repeated measurements, we can start to come up with an estimate of the velocity. Narrow down our understanding of where this particle, car, robot, whatever it is, and even start to make a predictive model of where it will be. That was the explanation that resonated with me. I hope that kind of works for you. It's a very simplified, quick explanation of a Kalman filter. What I'd really like to do in this video, of course, is to implement a Kalman filter using the stats library in R. So let's get started with that. So in order to do this, the first thing that you'll have to do, of course, is import your library. You'll want to activate the stats library so that you'll be able to get access to the Kalman run function. Here's the details of the Kalman run function. So Kalman run takes in a y parameter and then this model. And the y is a univariate time series. So that's like the location at time 1, the location at time 2, the location at time 3. And the mod is a model. And that model contains the transition matrix, the observation coefficients, the observation variance, V, which is RQR, the current state estimate, and the current state estimate of the state uncertainty matrix Q. Following through with this example, let's input all those things into a really simple Kalman filter. So here's our measurements. C just means create a vector. So this is measurements that say 1, 2, and 3. So something's kind of moving right along. The initial location state is going to be 0, 0. And the initial uncertainty will be 1,000. The external motion will be 0. The next state function is defined as 1, 1, 0, 1. And it looks like this. Measurement function H looks like this. And the measurement uncertainty is 1. And then we also have the identity matrix I, which you create in R by just writing diag. Once you have all this put into a model, then the command Kalman run takes measurements and model. Okay, and there you have it. I hope that was helpful. I hope you now have an idea on how to use Kalman run function from the stats library in R. Thanks so much, and we'll see you next time.